If it stops recording, let me know so I can throw it out the window. All right, here we go. So real quick review with this ionic character is what the regents will call it. When you subtract these two electronegativities, this is 3.1 and this is 2.4. So the rule is the larger the difference in electronegativity, this means it's more ionic, which means it has more ionic properties, which we're going to write down here in a minute. So more ionic, and we're going to put in parentheses here a greater or higher, I guess greater ionic character. That's how the regents will word it, greater ionic character. And again, what does this really mean? It means the Na plus and the F minus, those two ions are very positive and very negative. So again, the word there, electrostatic interaction. The electrostatic interaction, the attraction between these two, is really, really strong compared to these two. Yes, Al is +3. Yes, F is -1. So yes, they are attracted. It is ionic. There's a transfer. So it's a decent ionic compound, but it's not as strong as this one. And again, that's because there's a big difference in electronegativity. Really, it comes down to the Na and the Al. So we learned in the beginning of the year, group 1 is the most reactive metals, and this is kind of why. They make better compounds. A lot of it has to do with that electronegativity. So that's just some random question it could be on the regents. So I'm teaching it for that. And then the other reason is understanding that certain compounds are better than others. Why? If they're further apart on the chart, so group 1 and group 17, they usually make the best ionic because of that electronegativity. So that's the other part, right? We learn things for the test, and then also what's the real meaning? Like what are we trying to learn here? That the compounds are not all the same. Some are stronger than others, and that's why. All right. So that's kind of where we left off. I feel like a long time ago. And I'm kind of exhausted talking about ionics. It's been a while. So I'm going to give you the properties, which some of that homework went over, chapter 7, and the lab that we're doing right now is also going over properties. So I'm not going to really teach a lot. I'm just going to list them, explain quickly, and then we'll talk about them again in lab. So properties of ionics. And they are very strong. They have those strong electrostatic attractions, so they have high melting points. High melting points and boiling points. I'm just going to put BP. High melting points and high boiling points. Takes a lot of energy to melt. Takes a lot of energy to boil. Why? Because the forces holding the positive negative ions are strong. Okay, what else did we learn? We just went over it. You guys tell me another one.
They can conduct.
Good. So ionics conduct electricity, but only, capitalize, underline, only in solution, meaning dissolved in water, in solution, or as liquids. So I'm going to give you an example. If you have NaClAq, AQ means we dissolve salt in water. So if you have salt in water and you put electric current through that salt water, it will conduct and the current will flow from one wire to the other. Some of you who had lab this morning, you just saw that. I think that was beaker number 5. So it did conduct like 1.6 volts or something like that. Yeah. So it does conduct. If I was to take 2 of those wires back there, stick them in this, wouldn't conduct at all. Solids do not conduct. Solid ionics. What's the only solid material that conducts electricity? Metals. Metals or metalloids? But metals, yeah. So so this one here, this solid would not conduct. But if I was to melt it, so to get liquid salt, how would I label that differently than AQ? AQ means it's dissolved in the water. How would I write little L, right? Little L. And I don't write in cursive really, except for that L. This is kind of the only letter I do that for. And the reason is because you'll see that. You're not going to see just a straight line. They're going to do a little. So anyways, liquid salt also conducts. Now what these two have in common, Hannah said the other day. These two have in common. Anyone remember what she said? It was a while ago. Why does it conduct in water? Why does it conduct when it's liquid but not as a solid? Right now you guys are acting like a solid. let's say each one of you is a Na plus Cl minus, Na plus Cl minus, right? So you're alternating, Na plus Cl minus, Na plus Cl minus. Right now you guys are solid. You're not moving. You would be doing what? Aaliyah just goes. You'd be vibrating, very good. How would you demonstrate being a liquid or dissolved in water? Is it not recording anymore?
So it says like 10% reading.
Yeah, whatever. So, come on, stay with me. Right now you're solid. You don't conduct as a solid because you're not doing this. What could you do to show dissolved in water or liquid? What could you do? Move. Get up and move around. So what allows these two things to conduct? Movement of?
Particles.
More specific. What are you guys?
Ions.
Ions, yes. So I'm going to write the word mobile. Mobile means movement. Ions. Electricity needs something mobile to flow through. Metals actually have mobile particles in it moving around. That's why it conducts. We'll talk about it next week. But that's why solid salt right here, this will never conduct, not in the solid phase. You throw it in water. People always think what? Students always think, oh, I put it in water, it conducts because?
It does.
What's the misconception there?
Because of the water.
Right. Students think water conducts electricity. Water does not conduct electricity. What?
Wait, what? Really? How is that good?
You know the old like wives' tale or whatever that, however you want to, it's like cliche or whatever, you take a bath, your radio falls in or toaster falls in, you'll die, right? Yeah, it's like an urban legend or whatever. Yeah, if you drop your hair dryer or straightener or whatever, when you're using your straightener, and it falls into the tub, yeah, you might die. So don't do that, okay? But the reason that the bath water conducts electricity is because of all the ions in tap water and all the ions coming off your skin. Pure H2O doesn't conduct electricity. You just saw it today in lab. Didn't some of those beakers have zero?
Yeah.
That's because it was just pure water. Well, with a little bit of the covalent dissolved. Covalents don't conduct. Water is covalent. It does not conduct electricity. Pure water does not conduct. So kids get confused. They're like, oh, this is because water. No. It's not because of the water. It's because of the salt. So if water conducts electricity, it's because of what's dissolved in it, not because of the water. A lot of students don't believe me, and I'll show you in lab. Take some water, put those wires in, nothing happens. Okay? So this is really important to remember. Solids don't, only as solutions or liquids. What else? What else for the properties here of ionics? Colin said it. Last one here.
I say it again.
Yeah, right.
Hardness.
They're hard, right. So ionics are hard. Usually things that are strong forces, strong bonds, usually they are hard. So ionics are hard, but they break. They break easily, and let's draw that picture here. So you got your positive, negative, positive, negative, positive, negative, and then we'll just draw maybe three deep here. One. This is the second. Remember, alternate the second row, and then alternate the third row again, so it looks like the first one. It doesn't have to be super neat. Just get it down so we can get the gist of it. So this is what the crystal, right? Because ionics form crystals, a repeating crystalline structure. That's the way to say it. If you hit this third row here with a hammer, so lots of force, just like I went over on the homework, this entire row is going to slide. So now, you don't have to necessarily draw it, but you can just pay attention. It's up to you if you want to redraw. I can erase easily. So this would be missing. This would be positive, negative, positive, negative, positive. So now you have similar charges lining up. And if they're the same charge, what do? They repel. So all of these break off. So literally the salt crystal will break apart. Okay? Now, they will actually stay together as NaCl, for example, because there's other rows below it. But this row will be fractured, right? You'll have basically split those because they're repelling, because that force caused the crystal to shift. So that's why ionics break. Metals, they don't do that. Metals bend. We'll talk about it again next week. And there's similarities between ionic and metallic. That's why I'm kind of referring to that. But that's it. Those are the. And we talked about density. Talked about density a little bit. The density should be pretty high because they're really attracted. We don't need to write it down. But those are the main ones The only other thing I can think of is, does salt evaporate very easily? No. So let's just write this down. It has a low vapor pressure. Low vapor pressure. And what is vapor pressure? We learned that a long time ago. It's when vapor particles collide. So if there's no vapor colliding, therefore there's no vapor pressure. So because it doesn't evaporate, it has extremely low vapor pressure. That's the only other thing I could think of. And that's it. I probably went over actually since there's no bells. So no homework except for those of you who need to finish up that book work.